Hey guys and gals, today what we're going to go over is the parallel versus series parallel part of our calculation. So what we did last time is we did our series circuit. Here's our little diagram and here's our parts list. This parts list is going to be the same. What is going to be different is our calculation and our layout for our schematic. So I'm going to start with my schematic. And this time, what I want you to see is this time we're going to have multiple paths coming through. So I have my, let's see, let's make that long and make this short. And I meant to have it long, short, long. There we go. So this is our positive, this is our negative. I'm just going to bring it out just a little bit because I didn't leave myself a lot of space. And we're going to come out this way. And I said we have two paths, so here's what I'm going to do. I'm actually going to put the LED, let's come down just a little bit more here to give myself a little bit more space. I'm going to put my LED at the end, right here. It doesn't matter whether the resistors are before or after the LED. So what is important for you to understand, and this is going to be, I think, as far as the calculation goes, I made that all crooked, is I want you to understand that the resistors are in parallel with each other. The LED is in series. I know this is kind of difficult to understand, but when we do our calculation, we are going to calculate, let's see, here's our resistor number 1 and resistor number 2. Okay, so this is going to be R1, R2, and L1. So I have two paths, okay? So I have a path that can come through here to this LED, or I can have a path that comes through here to this LED. So what's happening is whatever value this is and this is, it's going to be less resistance than the smaller object. So let's start with our list. B1 equals 9 volts. L1 is going to equal, what did we say last time? 30 ohms. And R1 is going to equal, I think we said 100. And R2 is equal to 1000 ohms. So when we did this in series, what I want you to understand is our total resistance was 1130, which was 100 plus 1000 plus 30. This time, what's going to happen when we do our calculation is our smallest in our, oh gosh, what do you call it? In our parallel circuit, coming out of here, we're going to calculate this first, and then we're going to calculate our total resistance for our entire system. So we're going to calculate the total resistance of our parallel circuit. And then since this is in series with this little parallel setup, we're going to add our parallel calculation to this for our total resistance. And I want to repeat this again because it can be a little confusing. R1 and R2 are in parallel to each other. L1 and R1 and R2 So the calculation of this little parallel is in series with this. So we're going to do two total calculations. We're going to do a total calculation of our resistors that are in parallel, and then our resistors that are in parallel added to our resistance of our LED. So let's go ahead and create our section for our calculation. So let's come in here and do something like that. And then I'm going to say, I like to do this because it makes it look a little bit nicer. I don't know. So our total calculation, or our total RT, and I'm going to say RTP for parallel. So the two things that I have in parallel are these two resistors. So I have my calculation now this time is 1 over R1 plus 1 over R2. Okay, this is a little bit different. So equals 1 over 1 over 1 over 100 plus 1 over 1,000. So I'm going to bring in my calculator, okay? And I'm going to say, I'm going to do this a little bit different. I'm going to say 1 divided by, I'm going to put a parentheses, and I'm going to say 1 divided by 100 plus 1 divided by 1,000. And then I'm going to end my parentheses. And just so you, I don't know if it's been a while since you've done simple scientific calculation, but you have, it's going to calculate 1 divided by 100, and it's going to calculate 1 divided by 1,000, and then it's going to add them together. So it does our addition or multiplication and division, and then add and subtract afterwards, and then it's going to say that. So what I said earlier was we have 100 and 1,000. Oops, this is supposed to be 1,000. So this resistance, total resistance of this parallel circuit is less than the lowest number that's in there. So the lowest number is 100. This 90.909090 is less than that number. Okay, so that's how I know that it worked out right. So I have 90.90, I'm going to say 91. I'm going to round up to 4 digits, or round to 4 digits, single underline. And so this is my total resistance of this. Now our RT, which is our R total of the entire system, is going to be this parallel circuit, which is 90.9091 ohms plus, so now we went back to this same thing here where we have R1 plus R2 plus L1. So we have our R parallel, or RTP, plus our L1, which is 30 ohms. Okay? So our total resistance of this system, of the entire circuit, is, so 90.99, whatever. And I left this number because it'll be the closest round for my calculation later, plus 30. So 120.9091. That's my estimation. I'm going to leave that number in my calculator because I'm going to use that to make a more accurate number.